Hey there, welcome back to Calculus. In this short video, I want to demonstrate how you can investigate the values of limits using tables that you generate in a spreadsheet. In this particular video, I'm going to be using the spreadsheet Google Sheets. However, any spreadsheet software, the essence of what I'm going to do is basically going to be about the same. I already introduced the notion of limit in the lecture videos for section 2.1 and 2.2, so I'm assuming you've already checked those out before watching this one. And I also made a similar video making tables to investigate limits with the Desmos software. One advantage of Desmos is in addition to the table, you also get simultaneously a graph, so you can kind of visualize what you're looking at. Spreadsheets, there aren't going to be any graphs, so that's kind of a downside. But an upside of using spreadsheets is that it gives you more accuracy control. If you're trying to estimate values of a function to a certain decimal accuracy somewhere, then the spreadsheet allows you to control what accuracy you're looking at. Okay, the main skill I'm going to be using in this spreadsheet demonstration is cell referencing. Using spreadsheets is a very valuable skill, so actually hopefully what I'm going to show you here in this short video is going to be useful to you well beyond just applications in your calculus class. Okay, so what's the example we're going to use? Spicing it up a little bit. This is something that's not completely unlike a problem that you might see in some of your section quizzes in the course in the MyOpenMath, but I want to use a table of values to estimate this limit, or maybe I don't even know if this limit exists written down. It certainly can't be evaluated. This function doesn't. The function cosine of 11x minus cosine 5x over x squared doesn't have 0 in its domain. So I can't just evaluate this function at x equals 0, but as usual, I want to ask the question like, well, what are its values near, if anything, when x is close to but not equal to 0? All right, so I'm going to switch over to my spreadsheet window. I've got it ready to go. Should bring that into view. Again, I'm using Google Sheets. If you're using some other spreadsheet software, the general layout of it is the same. I'm going to go ahead and magnify this a little bit so it's easier for you to see what I'm typing. All right, so I'm assuming you're basically familiar with spreadsheets and that they have these cells, and cells are located in rows, which are enumerated with numbers, and columns, which are enumerated with letters. All right, and then there's nothing sacred about which column you start in or so on, but I'm just going to start in the upper left. You also don't need to make headers, but I kind of, when I use a spreadsheet, I like to. So I'm going to put some headers. I'm going to type the values of my input variable x in this column A, and then the function, that cosine of 11x and so on, its values are going to be in the second column B. So I'm just going to type f of x. All right, so I'm assuming that f of x is that function cosine of 11x minus cosine of 5x over x squared. Okay, and then I'm taking the limit as x goes to 0, right? I'm interested in the limit of this function as x goes to 0. So in my x column, I'm going to choose a bunch of numbers that are getting closer and closer to 0. I think I'm just going to use that same kind of pattern that I used in the lecture videos and the Desmos video. Just choose numbers. I'm just going to type them in here. So I just clicked the cell and I'm going to type the number 0.1 and then enter it. Right below it, maybe the number 0.01. Right below that, 001. That's 1,000th. I think I'll go one more. It's 10,000. And like we mentioned in the lecture video and in the Desmos video, if you've checked it out, these numbers are all close to 0, bigger than 0. I also need numbers that are close to 0 that are less than it. So I'm just going to choose the opposites of those four numbers. So just give me a second here to type that stuff in while I'm trying to talk and type at the same time. 4 zeros and a 1. There you go. So I'm going to be evaluating, at least initially, maybe I'll need some more data, but initially I'm going to plug these 8 numbers into the function. All right. So what do I do in the f of x column? Well, I'm going to start in this row, the top row where I've inputted the input value equal to 1. And instead of just typing the cosine expression, which I certainly could, but the whole point of doing this is I only want to type that once. So I begin by starting with an equal sign, okay? And you can already see that the spreadsheet is sort of detecting that I'm going to write what the spreadsheet language is a formula. So I start with this equal sign. It's important that I do that. Okay, I'm also got a fraction, so I'm going to group its numerator and denominator. I'm going to put those parentheses in there right now. In a spreadsheet, it's very important because it doesn't format as nicely as it does in Desmos, so it's kind of harder to keep track of sort of where you're parenthesizing things. So these fractions are for my numerator. And then what do I have to put in? That cosine. So I'm just going to type COS. And the spreadsheet is smart. It knows a whole bunch of functions with COS in them. I'm going to choose this one. It capitalizes it because that's its syntax, but I just chose the cosine, right? And it gave me a left parenthesis for the cosine's argument. So I have cosine of 11. I'm going to use Shift 8, the star symbol for multiplication. It doesn't understand just juxtaposition. You have to put in that star symbol for multiplication. But now I'm not going to type X. And I'm not going to type 0.01. This is the cell referencing part. Instead, I'm going to put the mouse over here for the value that I want X to be. It's in cell column A, row 2, and I'm going to click it. And notice that in sort of a different color, the spreadsheet has put A2. So I've referenced whatever the value in that cell is. Right now, that value is 0.1, but I've just referenced the cell. Okay? Then I'm going to close those parentheses because that's what I'm taking the cosine of, 11 times that value of A2, and then subtract cosine, do the same thing, 5 times reference the cell and the parentheses. Okay, so that's how I tell the thing, take the cosine of 11 times the number in that cell, A2, minus the cosine of 5 times the number in that cell, A2. And then keeping track of my order of operations outside that parenthesis, I'm going to hit the division symbol. And what do I want to divide by? Well, I want to divide by x squared in my formula, right? So that's the number that's in that cell, currently 0.1, squared. You can use that caret notation. Okay, so maybe it's a good place to pause this video and sort of look. This is how I've entered the formula, cosine of 11x minus cosine of 5x over x squared, where x is the value in the cell A2, but I've done it referenced. And now I'm going to hit enter on my keyboard. And well, what is in column B, row 2? It's the value of my function when x is 0.1. Notice that this software is super fancy. It's actually anticipating what I want to do. It's asking me to suggest this autofill. So I can just literally click this green check mark and say, yes, I do want to accept it. Or if you had something else in mind, you could reject it. But what does it mean by autofill? This is what referencing does. It's taking that formula that we typed in, that cosine of 11x minus cosine of 5x over x squared, but it's evaluating it in each row with the number that's in column A. So it's precisely taking these 8 different values and evaluating them all in that function. All right. So if I just accept this, then there's my table. Okay. That's the table of values. And using this table of values, I think we have a pretty good idea of what this limit looks like. It looks like it exists, and I can kind of take a guess at what its value is. I'm going to show you, just in case that you don't accept that autofill or it disappears, you don't have to panic. Here's my referenced cell. Okay, it's the only one. And you'll notice that in the lower right-hand corner, there's this sort of little blue box. I don't know if you can see my cursor, but when I move the cursor over the little blue box, it changes to a small cross. And if I do that, if I click and hold that thing and then drag it down, this is another way of instructing the spreadsheet to take the referenced cell and perform the same formula, but do it on the corresponding rows, okay? So notice if I click on any one of these cells up here in what's called the expression bar, right now it's telling me that it's computing that value, the cosine of blah, 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 using the number that's in A2. It's written in orange. If I click below it, aha, that's referencing A3. Click below it, that's referencing A4. Nice. Okay, I'm going to end this here because I want these videos to stay short, but I do want to say one more thing about accuracy. Here, my spreadsheet is displaying how many, 7 places after the decimal to make these calculations. Up here in Google Sheets, there's just 2 buttons. One of them is decrease the number of decimal places. One of them is increase the number of decimal places. So if you were instructed to do this to say 8 or 9 decimal places, you can do that. Okay, I'm doing it to just that one cell. If I can select the whole family of cells and say, increase the number of decimal places to 8, increase the number of decimal places to 9. You can increase it to any number of decimal places that you want, or you can decrease it to any number of decimal. Maybe you're satisfied with things being to the nearest hundredth. Okay, well, to the nearest hundredth, here's these values. And yeah, maybe I'll leave it as a mystery, but can you use this table to estimate the value of the limit that we're after? Okay, so I hope that was useful, and I hope you use spreadsheets to do some of these numerical calculations in your assignments on Canvas. And thanks for listening.